Hello people viewing this video. Today we are working with some biconditional statements and counterexamples, at least in my second day of logic. And here we go. Starting out with what counterexamples and biconditionals are going to be talking about. Basically, sometimes you say things that are true, and sometimes you say things that are false. And biconditionals kind of talk about things that are true all of the time. There are things that are kind of like definitions. You'll use biconditional statements. It's something where like normally you have the hypothesis and the conclusion, and in a biconditional, it's saying, you know, an if this then that, but it also works the other way, the converse, that they're both true for. So things that are going to be biconditionals are things like a right angle. Something is a right angle if and only if it is 90 degrees, because the definition of a right angle is 90 degrees. Things like that. So biconditionals are very common when it comes to definitions, whereas counterexamples, what we're starting here, is what you use to prove people are lying or prove things are not true. And here it is, it's just a specific example that proves the statement false. And then here's a small and quick and easy example to understand. So it says, for example, if you are at school, then it is Monday. And you know, if you think about it for a couple of seconds, if you're at school, then it's Monday. And it's like, well, that's not always true, right? So this statement is false. It's because in order for it to be true, it's like no matter what, if you're at school, it has to be a Monday. That would mean you cannot go to school any other day but Monday. And hopefully you can realize that that's definitely not true. So if the statement is false, you can write a counterexample. So all you have to do to prove this wrong is to tell me a day that you are at school that's not Monday. So if you are at school, then it is Monday. Well, can you think of a time where that's not the case? Maybe. How about Tuesday? At Tuesday, you would be at school, but it would not be Monday, right? And by at school, I mean like distance learning right now. School is our online school because COVID and stuff. So if you're at school, then it is Monday. Well, what about Tuesday? Right? If you're at school, then it could also be a Tuesday. It could also be a Wednesday. It could also be a Thursday. It could also be a Friday, right? There's all these days where you would be at school that aren't Monday. Now, there could be more than one counterexample, but you only need to list one. Because if you were to try to list everything, it just gets to be too much. Some statements in math are like about specific numbers, and then to write a counterexample, you'd have to write literally every other number in existence, which takes too long. So you just need to tell one specific case that is false in order to make a statement false. This says you try. If the statement is false, give a counterexample. So all figures with four sides are squares. So if you think of something with four sides, does it have to be a square? And for me, it's like, well, no, there's lots of figures with four sides that are square. That are not squares. So all you have to do is list one type of figure with four sides. So just think about it. What's another figure with four sides? That's not a square. And most people will say rectangle, and you only need to provide one. I could have written rhombus. I could have written parallelogram. I could have written trapezoid if I felt like it. But just one thing you need to put. You do not need to put more than one. Next up, it says all squares have four sides. So is that true? Can you think of a square that does not have four sides, right? It's talking about all squares. So is it possible to think of a square without four sides? If, you know, my pen decides so. There we go. All squares have four sides. So is it possible to picture in your mind a square that does not have four sides? Nope, that one's just true. All right. Doesn't, like, you have a square, it has 4 sides. If you play basketball, so I'm just gonna go ahead and highlight this because I like highlighters. If you play basketball, then you are taller than 6 feet. So if you think of someone playing basketball, do they have to be taller than 6 feet? Can you picture anyone at all in existence playing basketball that is not over 6 feet? And, well, I would hope so. There are people in elementary school who play basketball, right? Not professionally, but they definitely play it. They may throw the ball, and it might not even get halfway up to the net, but they can be playing it. So sure, if you play basketball, then you are taller than 6 feet, just say, no, why not? And then you just have to list someone who plays basketball and is less than 6 feet. So how about my son, Jason? Yeah, he's 5, so no, he's not going to be. So there you go. That's it. Next up, if you live in Virginia. So, if you live in Virginia, then you are from Leesburg. So, can you think of anyone who is living in Virginia, but not from Leesburg? And yeah, Virginia's a big place. Leesburg's a small place. So all you have to do is tell me someone who lives in Virginia, but is not from Leesburg. And, there's a lot of people. In this case, you could probably just say, hey, someone from Fairfax, or hey, someone from Manassas. So anything like that. So if you're from Virginia, you're not from Leesburg. No. Could be Fairfax. Why not? A person in Fairfax lives in Virginia, but they are not from Leesburg. If you are from Leesburg, then you live in Virginia. So is that true? This time, if you picture someone living in Leesburg, does that mean they have to be inside of Virginia? And, to be honest, I'd probably accept either answer to this, because Leesburg, like, if you were living in Leesburg, then yes, you have to be part of the bigger Virginia area. However, if you're thinking, I guess, literally outside of the box, there are different places called Leesburg besides the one in Virginia. So if you were kind of having that mindset, you could say false. You could be in Leesburg from this other state that has a place called Leesburg. But that really just depends on how you personally define the word Leesburg, to be the area right here or to be any city called Leesburg. But I'm going to be putting down yes. If an animal can swim, then it is a fish. So if an animal can swim. So if you are thinking of an animal swimming, if anyone was to picture an animal swimming, does that animal have to be a fish? And, well, no, there are lots of animals that swim besides fish. You could write a jellyfish. You could write a polar bear. You can write penguins. All of these things can swim, but they are not fishies. So I'm going to go with jellyfish. Ta-da! I'll write no as well. All right, moving on to biconditional statements. Biconditional statements, you can only write these if both an original if-then works, as well as its converse. Converse is the one where you switch them, if they're both true. Because normally, in an if-then statement, you write it like this. If P, then Q. The converse is if Q, then P. So what they do, those sneaky devils, is they say, if you have a P and this arrow is pointing towards the Q, and here there's a Q and an arrow pointing towards the P, well, what if we have this arrow from P to Q, and then we have this arrow from Q to P, and we just put those two symbols on top of each other, and guess what? That is the symbol for biconditionals. This is just saying P goes to Q and Q goes to P, both at the same time. P goes to Q and Q goes to P. Sneaky sneakies. So steps to writing a biconditional, it's actually not terrible. Usually what happens is you have an if statement and then a statement like that. What you're going to be doing is you're going to take out the word if and then, and you're going to have this and then write the words if and only if, and then the second statement. And that's what happens. You just go through it, and if it is a biconditional statement, you take out the word if and then, just cross them out or erase them or whatever, and then insert inside of the middle the if and only if. And that's it. Determine conditional. So, determine, first of all, if it is a biconditional statement, if it is true both ways. And then, it just says it here, whatever. So. If an animal meows, then it is a cat. Well, if you picture something meowing, is there any other creature besides a cat that meows? And that is no. People came up with the word cat before they came up with the word meow. They were like, hey, look, it's a cat. And they were like, oh, it's a kitty. Look at meow, meow. And they came up with that sound, and then they put that sound into a word called a meow. It is literally something that is done only by cats because it is defined by being from a cat. So this is going to be true. If an animal meows, then it has to be a cat. And then the other way is around. If it is a cat, then it meows. Right? So both of these are true. If it meows, it's got to be a cat. If it's a cat, then it's going to meow, right? So both the conditional and converse are always true, so you can write it. Instead of my whole, if-then thing, I would just say not the if, not the then, but instead I'm going to put the whole if and only if thing right here. So, it is a cat if and only if it meows. An animal meows if and only if it is a cat. So let's just switch in those two things because, I wrote the switcheroo thing. But these are both good statements. An animal meows if and only if it is a cat. This IFF thing is a symbol mathematicians sometimes used to represent if and only if because we are a lazy bunch and we don't like writing things, which is why we say, hey, let this X be anything instead of writing the word anything. But you guys will have to write out the if and only if, so I know that you know what it means. So do not use the IFF unless I say it is okay. Okay. Here's some practice example problems. So I'll do one or two, then you guys should pause it and see if you can do it, and then I'll give you the answers. So decide if it is. So if I wear my snow boots, then it is snowing. So if you're wearing snow boots, they're literally called snow boots, right? Do you wear snow boots when it is not snowing? Well, not really, because then they're just called boots, right? Now, you can purchase boots in the winter time, but they're still just boots until you're actually wearing them in the snow. So this has to be true, because otherwise they're just boots. You don't say, hey, look at my snow boots. I'm wearing my snow boots in July, ha ha ha. No, they're just boots at that point. If I wear my snow boots, then it's snowing. That's true. How about the other way? If it's snowing, then wear snow boots. So if it's snowing, then you wear your snow boots. And yes, that's true. the definition of snow boots is what you're wearing while it's snowing. So this is also true. So this can be written as a biconditional. So I'm going to take out the word if, going to take out the word then, and this then part is going to become my whole if and only if statement part. And I'm just going to write what it says. It says, I wear my snow boots and then if and only if. It is snowing. Ta-da! For number 8, it says if x squared equals 25, then x is 5. Well, if x squared equals 25, then x equals 5. So can you think of a number that when you square it, it is 25? That is not this number. So is there any other number that when you square it, it equals 25? Is there a different number? The answer to that is actually yes. There is a different number. I can come up with a counterexample to this. It's not true. If x squared equals 25, then what about negative 5? Does this guy not exist too? Is he chopped liver? I mean, come on, people. If x squared is 25, then x equals 5. Well, Mr. Negative 5 over here is like, sad face, what about me? Don't I exist? Don't I matter? And the answer is yes, Mr. Negative 5, you matter. And he's like, yay, Mr. Anderson, thank you for my acknowledgement. Negative 5 also would work for this. Negative 5 squared equals 25. So it doesn't have to be that x equals 5. X could also be negative 5. So that is a counterexample. So once again, go through these, see if they look like they would work both ways, that it's true in both directions. This way to that way or that way to this way. Things to think about are like definitions. If something is a definition, then it's definitely going to be a biconditional. But okay, so go ahead, pause the video, do these, and then come back and see if you got them. Okay, here we go. If today is Saturday or Sunday, then it is the weekend. Yes, the definition of a weekend is that it is the Saturday or Sunday. So today is Saturday or Sunday if and only if it is the weekend. You know, if and only if it is the weekend. If it's raining, then the sky is dark. Well, no, even that technically is not true. Have you ever seen the rain coming down on a sunny day? Yes. Sometimes it is, and those days are awesome, by the way. So this is not even true, so that's false. It could be, counterexample, just a sunny day. If you've ever wondered why it can rain on a sunny day, it's because the rain comes vertically towards you, but the sun can be over here towards like 4 or 5 o'clock, coming down at you. So even though you have rain clouds here, you have the sun coming over here, and then you're over here in heaven because that's so awesome when it happens. Even if you don't think of thought of that, you could still go the other way. If it's dark, then it's raining. Well, what if it was dark because it was nighttime? You know, there's other reasons that it can be dark besides it raining. So either way, you could also say nighttime if you felt like it, night. Because at night it is dark, but it is not raining. So you can't say it's raining if and only if it's dark. If Tony has the fastest time, then he wins the race. Yes, the definition of winning is you're the first one there. And if you are the first one there, then that means you have to have had the fastest time. So this is true as a biconditional. So Tony has the fastest time. If and only if he wins the race. So if he wins the race, he had the fastest time. If he has the fastest time, then he'll win the race. unless he gets disqualified. Oops, sorry, I'm not supposed to say that out loud. If Felipe is a swimmer, then he is an athlete. So are all swimmers athletes? Yeah. What about the other way? Are all athletes swimmers? No. What if they do, I don't know, horseback riding, right? Equestrian the arts, or gymnastics, or basketball, or cheerleading, or football, or any of those other sports, you know? Those athletics, you can be any of those things, but not be a swimmer. So I'm just going to put down, I don't know, I like playing soccer, so I'm gonna write soccer. You could play soccer, and still be an athlete, so there you go. That's it for these notes. Hope this was helpful to you. And I'm sorry for this video being so long, but that's just how I roll. So, peace.